In lesson 6.9, we're going to multiply polynomials. And just like we did with addition and subtraction, we started with a model and then we transitioned to using the process without the model. We're going to do the same thing with multiplication. We're going to start with the model like you did in the last lesson, and then we're going to apply that process to polynomials that maybe don't exactly fit that structure but follow the same process. So a key thing to remember when you're multiplying is that if you use a variable more than once as a factor, then the exponents will change. When we were adding and subtracting, exponents didn't change because exponents indicate repeated multiplication. So when we are multiplying repeatedly, you will see those exponents change. Let's start with our first example where we have a monomial, 3x squared, multiplied by a monomial, negative 2x. Nothing inside either one of those groups is added or subtracted to anything else. These two monomials are multiplied by each other. And we can multiply the factors of those monomials in any order we want. So what we're going to do is we're going to take the number parts, the 3 and the negative 2, multiply those together, and we're going to take the x squared and the x and multiply those together. You don't have to write that step, but that's how you want to think about it. Multiply the number parts together. 3 times negative 2 is negative 6. And multiply the variable parts together. So I have x to the second power times x to the first power. That's 3 factors of x. So x to the third power. The exponent counts the factors. In the next example, we want to multiply the monomial, which is just a constant term, negative 8, by the group, which is a trinomial. It has 1, 2, 3 terms in it. So the negative 8 has to be multiplied by each of those terms, just like that. You can draw arrows to remind yourself of what you're doing, or you can write it out. But we want to multiply negative 8 times negative 3c. When we multiply negative 8 times negative 3, we get a positive 24. We still have that c squared factor. Now we want to multiply negative 8 times negative c. Negative times negative is positive, and 8 times c is just 8c. Then we multiply negative 8 times negative 2. Negative times negative is positive, and 8 times 2 is 16. Now we're looking for like terms, but we don't have any like terms, and so this is our final answer. In the next example, we have a monomial, this time with 2 factors. 2c is still a monomial because it's one term. And it is multiplied by a group that has 2 terms in it, 1, 2, so this is a binomial. We're going to multiply the 2c times the first term, and then we're going to multiply the monomial times the second term. 2c times 4t, or 4c squared, multiply the numbers first. 2 times 4 is 8, and c times c squared is c to the third power, or 3 factors of c. Multiply 2c times negative 2c, a positive times a negative is a negative, so we're going to write this minus. 2 times 2 is 4, and c times c is c squared. There are no like terms there. We can't add or subtract if the variables don't have exactly the same power. That's how we know this is our final answer. Now think about the models that you did in your last lesson. This is an area model, and you should be able to tell me which factors are multiplied together to give this area model. If I look along the edge, this length is x, this length is x, so I have 2x along this length, and then 2 units. So 2x plus 2 is the length of the area model across the top. If I look down the side, then I have an x length right here, and then 3 unit lengths right here, so x plus 3 down the side. So what we'd like to do is not have to draw that picture, but we can use the idea of this box. So instead of drawing the model, we're going to draw a box, and then we're going to make 2 rows and 2 columns, since we're multiplying a binomial times a binomial. Now notice if I multiply the 2x times the x, then that gives me the 2x squares that I have right here. Instead of drawing the picture of the x squares, I'm just going to multiply 2x times x and write the symbols, 2x squared. If I multiply 2 times x, then that goes in this box over here. I have 2x. If I multiply 2x times 3, then I get 2 times 3 is 6x. And that's how many x's were in my model. If I multiply 2 units times 3 units, then I get 6 units right here. Let me write that out to the side so you can see what it would look like without the model. If I'm multiplying 2x plus 2 by x plus 3, I need a 2 by 2 box. I multiply 2x times x and put 2x squared where that column and that row intersect. Multiply 2 times x and put that right there. 2x times 3 gives me 6x in this box, and 2 times 3 gives me my units here. Now I want to add up everything that's in the box. So 2x squared plus 2x plus 6x plus 6. These are like terms because they're exactly the same variable raised to exactly the same power. So I'm going to add those terms together. These terms are often in the diagonal of our multiplication box. So we can add them together as we write the answer. 2x squared plus 8x's, and since we're adding there, the exponent will not change, and then plus 6. This is our simplified answer. Let's find the product of these two binomials. So I need a 2 by 2 box. It doesn't matter which factor you put across the top and which factor you put down the side. That order does not matter. Now I want to multiply 4w times w, which gives me 4w squared. Negative 2 times 4w is negative 8w. W times negative 3 is negative 3w. And negative 2 times negative 3 is a positive 6. Now I want to add up everything that's in the boxes. So I have 4w squared. And if I add these like terms in the diagonal box, negative 8w and plus negative 3w is negative 11w. And then I need the plus 6. The next example looks a little bit different, but remember that when you have an exponent that's next to a group, that means that you're using the group as a factor 2 times. Just like x squared is x times x, if I have 4p plus 1 squared, then that means 4p plus 1 multiplied by 4p plus 1. So that group is used as a factor twice. That's a binomial times a binomial, so I need a box that has 2 rows and 2 columns. 4p plus 1 multiplied by 4p plus 1. Pause the video and fill in this box, combine your like terms, and then come back and check your answer. Check your multiplication to fill in the box, and then remember to add the terms that are inside the box, combining like terms if there are any, to get your final answer. Compare our next example to the ones that we worked before. We have a polynomial multiplied by a polynomial, but this time our first polynomial is a binomial with 2 terms, and our second polynomial is a trinomial with 3 terms. That just means we need a bigger box. So let's draw a box that has 2 rows and 3 columns, or you could do 2 columns and 3 rows. I'm going to put my 4z plus 3 down the side because I have 2 rows. And then I need a z squared, a minus 3z, and a minus 3 on each of my columns. After you set it up like this, your process is the same as what we did before. We're going to multiply each row and column where they intersect. We're going to put that product. So if I have 4z times z squared, then that's 4 times 1, which is 4, and z times z squared, which is z to the 3rd power. Now multiply the negative 3z times the 4z. Negative 3 times 4 is negative 12, and z times z is z squared. Negative 3 times 4z is negative 12z. Z squared times 3 is 3z squared. Negative 3z times 3 is negative 9z. And negative 3 times positive 3 is negative 9. So I have a lot more cells in my box, and I multiplied to fill them in. Now I want to add any like terms inside the box. You might notice that on this diagonal I have like terms because I have negative 12z squared and 3z squared. The variable and the power on the variable are exactly the same. In the next diagonal box I have like terms as well. Negative 12z and negative 9z can be combined. So when we write our final answer, we're going to have 4z to the third power, which has no like terms. Negative 12z squared plus 3z squared is negative 9z squared. And negative 12z plus negative 9z is negative 21z. And then our constant, negative 9. Remember, when you're adding, the exponents do not change. When we were multiplying, we changed the exponents. Let's use our skills of multiplying polynomials on some simple applications. When we want to find the area of a polygon, we have a formula. For a rectangle, we're going to multiply base times height. Same thing for any quadrilateral. For a triangle, we have a different formula, 1/2 the base times the height. Pause the video and set up the multiplication for each of these areas, and then come back and check your answers. For each of the quadrilaterals, we're multiplying the base times the height. So if I have more than one term, then I put that in parentheses, like my 3x plus 3. So in the first example, I'm distributing the 2x through the group 3x plus 3, and an expression for the area that's simplified is 6x squared plus 6x. If I look at this polygon up here, it's a quadrilateral, so my formula is still base times height, so 8 times 3x. This is a monomial times a monomial, so we just multiply the number parts together, and then there's only one factor of x, so our answer is 24x. Now when we set up the area of the triangle, we have to remember the formula is 1/2 the base times the height. So the number 1/2 is a factor, 2x plus 8 is a factor, and 2x plus 3 is a factor. You can multiply those in any order. I could multiply the two groups together and then multiply that by 1/2. Or I can distribute the 1/2 through one of the groups first and then multiply those two groups together. I'm going to distribute the 1/2 through the first group. 1/2 times 2x is just x, because 1/2 and 2 are reciprocals, and when I multiply them together I get 1. 1/2 times 8 is half of 8, which is 4. So that gives me this group left over from that multiplication, and that needs to be multiplied by 2x plus 3. Since that's a binomial times a binomial, I might put that in a box to organize my multiplication. So x plus 4 multiplied by 2x plus 3. When I multiply to fill in the box, I take those terms and add them up. Combining like terms, I get a final answer that you see here. Make sure that you complete your practice and then you're ready for your mastery check. And as always, ask me if you have any questions. I'm happy to help you.